Good readings and welcome, ladies and gentlemen. We were talking about solving rational equations, specifically word problems related to them yesterday. And we're on page like 581 and 582. Here's question 4. I like this problem. It says, you decide. Rick solved the rational equation, blah, and told his friend Janine that the solution was 2. And Janine said, you're right, Rick, but there's another solution to the equation. Actually, that's like a compliment, a backhanded, you're wrong in your face meant right there. Yeah, because technically, Rick, you're wrong.
It's like when
you're
someone
wrong.
said, oh, I really like your shirt. Where'd you get it? The thrift store?
Oh, wow. Just like that. That's essentially what Janine said. I like your answer too, but you're missing the other answer, Rick. And that's what she said. And then Rick said, showing her his solution, he says, no, that's not true, is what he says. And then she's like, and he's all like, that's impossible, kind of like Luke Skywalker when he's confronted by his father. And he says, it says, look at Rick's solution at the right. Who is correct? Explain. So let's see. Let's analyze from one step at a time. All right, so here's the original problem. What happened from here to here? What did Rick do?
He put the LCD to both.
No.
Subtracted x.
What happened to this?
Divided by.
He divided both sides by x plus 3, right?
Which is the LCD.
No.
What is the LCD then?
Oh, it's not that. It's 5 times x plus 3. Well, 5 is the LCD, actually. So he divided by that, okay, on both sides. And this is what he gets, right? And what happens between here and here?
You cancel out that plus 3 more than one time.
Yeah, he cancels this out with that. Is that a legal cancellation?
Yeah.
Yeah, it is. Yeah, it's perfectly fine. So he does that, and now he's got this, and then what does he do from here to here? Multiplies by 5, and then he subtracts 3. And 2 is one of the solutions. Now, the situation that occurred was in the dividing by this, all right, and canceling out, he actually eliminated one of his potential solutions. All right, the way you're supposed to solve this is multiply both sides by the LCD, where I would end up having multiplied both sides by 5. I would have gotten x plus 3 all squared equals 5 parentheses x plus 3, right? And then I could FOIL this out. We don't necessarily have to do this whole problem. Well, we'll see. We'll see. X squared plus 6x plus 9 equals 5x plus 15. And it's a quadratic. Now, that's what I want to point out. This is a quadratic. Rick ended up solving a linear problem, right? This was an x to the first degree once he did his little cancellation. And a linear problem is only going to ever have at most one solution. All right? I guess technically you could have an identity form out of it, but nonetheless, it's not going to have just 2 solutions, which is what a quadratic potentially could have. So we would then subtract 5x from both sides, and 15 as well. And we'd get x squared plus x minus, what's that, 6 equals 0. And if I factor this, this is going to end up factoring to be x with a 2, x with a 3. Equals 0, a minus 2 and a plus 3, and we'd get x equals 2 and x equals negative 3. So notice Rick did not get that negative 3 solution because he canceled out, which eliminated the potential for finding that other solution. Okay, so that's just an interesting thing. It doesn't happen a lot, this sort of scenario, but sometimes students try that sort of thing where they cancel something out and then end up eliminating a possible solution. They're not finding the full answer, so to speak. So so let's see, who is correct? Well, it turns out Janine is correct, and the explanation was because he canceled out one of the solutions. Actually, what does the old Libro say? It says, Janine is correct, the other solution is negative 3. To avoid losing a solution to an equation when you divide each side by an expression that involves a variable, check any numbers that make the divisor 0. Aha, so apparently by doing so, because by doing the dividing, that meant negative 3 wouldn't have been a solution, and that's why it eliminated that. So if I checked that -3, I actually would have found that to be a solution here as well. Interesting case, because -3 is okay in the original problem, right? -3 is like, this is cool. But right here, -3 is not cool. It's all like, I hate -3 because that gives me a 0 in my denominator. So that's why we've got to be careful when we manipulate an equation in that way, dividing by a variable. So let's see, 35. During 1/4 of the time it took her to travel from Denver to Cheyenne, Alicia drove in a snowstorm at an average speed of 40 miles an hour. She drove the rest of the time at an average speed of 65 miles per hour.
Fast for a snowstorm.
Let's see. She drove the rest of... I'm assuming that was during the not snowstorm. Because she's going from Denver to Cheyenne. I don't know where Cheyenne is. But anyways, I'm assuming Cheyenne was not necessarily having a snowstorm at the time. Who knows? So anyways, where is it? What? Wyoming. There we go. That would make sense. There we go. Let's see. So the rest of the time at an average speed of 65 miles per hour. What was her average speed for the entire trip? Okay. So this is going to relate to, let's see. Actually, whoa. During 1/4 of the time it took her to travel from Denver to, she drove 40 miles per hour. So, okay, so 1/4 of the time, let's just write down our facts. So 1/4 of the time, she was traveling how fast? 40 miles per hour. What's a fraction that would describe the rest of the time? 3/4 of the time, she's traveling 65 miles per hour, right? And I know that the average of all of her overall speed, actually, oh, that's what we're interested in, is the average. Okay, I don't necessarily know how I'd solve this using directly rational equation stuff. It's more kind of like adding fractions in my mind. But let's see, what was the average speed for the entire trip? So I guess that's my variable. I'll say x equals average for whole trip. Okay, I guess I could try to make this a rational equation. So my equation, question, how do you find the average of numbers?
You add them up and then you divide.
Yeah, add them up and divide by how many there are. Now in this case, I could actually think of this 1/4 of the time as being like add 40 once and add 3 65s. All right, because 65 is occurring 3 times as much as the others, so you could view that as kind of like weighting that as more influential. And of these 1 out of 4 and 3 out of 4, there were 4 values that were considered overall. So let's see, so my average time for the whole trip, you could have thought of it as 40 plus, you could think of it this way, 65 plus 65 plus 65, all divided by 4. Or a better way to perhaps think of that, because writing 65 plus itself multiple times isn't necessarily the most efficient, I could think of it as 1/4 of the time she's traveling 40 miles an hour plus 3/4 of the time she's traveling 65 miles an hour. All right? So that's going to essentially accomplish the same thing. So to solve this, well, it's already solved for x, and that's why I was saying it's not necessarily like a rational equation per se. What's 1/4 of 40? Or actually, you know what? Let's write it this way. 40 quarters plus, what is 3 times 65?
It is
180 plus 15, 195?
195.
Is it 195? Yeah. I think I agree. So 195/4. And if I add those together, the numerators, because the denominators are the same, 195 plus 40 is going to be what, 235?
Yeah. That's good. Right there.
And I'm going to get x equals, let's see, 235 divided by 4. Well, what do you know, Joe? 58.75. So the answer would be, let's see, what was the question? Who was this about? This isn't Janine anymore. This is Alicia. Alicia had an average moving speed
saw a picture of a book last night, and it was gas prices, and they were like $1.
Isn't that funny?
Yeah, I laughed. And I was like, because you brought up how like contemporary it was when we talked about what Manning or
Peyton Manning, yeah. Mm-hmm. So our book talked about gas prices for $1. I could see
Is
that.
that
So anyways, so thanks for watching, internet friends. Tienen un día el más bien del mundo.